Yeah, so I will tell you very shortly about the Autoplant project, concepts and tests of autonomous forest regeneration. And we can discuss this matter much more tomorrow at the excursion, especially at the Luleå University point with the Auro platform. So we have this project that is a part of Sweden Innovation Agency's program for challenge-driven innovation. So the project group itself that has to collaborate defines the societal challenges and try to provide a solution for it that helps contribute to the sustainability goals in Agenda 2030. So this is not just only an ordinary technique project. So our specific aim was to develop an autonomous forest regeneration system with high precision, low environmental impact, and a good working environment. And what we have been carrying through now for 2 years was the step 2. And there we have kind of focused on developing and testing different sub-projects. And I've already told you about the Pathfinder product. Together, this should form some kind of prototype if we proceed to step 3 and end there. And we're now writing this application, so we hope we can tell you more about this. So, and one of so this is actually the different parts of the system. We have a mission supervisor that is the like machine brain, and we have a plant planner that we will see much more about tomorrow at the excursion. We have the global plan that I've talked about, the local plan, crane movement, motion planning, and so on. And the actual hardware that Brakke Forest have developed, and also some kind of seedling documentation with the photos. And the obstacle detector, of course, that was developed by Luleå. So after 1.5 years, we tried to put all this together in the field and do some kind of demonstration, but it's very far from a product, but at least we were able to demonstrate autonomous site preparation and planting. And when it comes to the hardware, Brakke Forest went from like 45 different soil scarification prototypes and ended with 3 different types. And for the field test, we used the middle one with a kind of a drill, but they're working on different types. And they also worked more on the robotic arm for plant feeding, as we have discussed previous today. This is a bottleneck or a problem to solve because the seedlings are very easily damaged and so on. And they also developed the integration with the Luleå's vehicle platform, so we could put everything together easily. Yeah, so, and then the vehicle plankton, obstacle detection and planting point selector. You have already heard about this platform. And here you see a picture where we have integrated Brakke's parts with the head and the plant feeding system and so on. And let's see if I can start this now. Yeah, so, and here you see the planting spot selector that uses the obstacle detection to see where not to plant and then try to plant with different success. And this here you see the digital twin doing it, but we will see it in like real time tomorrow, but not with the actual head, but the motion planning and everything. I will talk more about that then and L2 as well. Yeah, and then we have the path planning, as I've already described, and also the route planning, that like the local plan. And that was made by KTH. So they kind of use this mostly image data to create a 3D environment just in front of the machine and manage to see obstacles like stones and so on, to avoid them and return to the global route that was provided by Pathfinder. Yeah, and I was then going to stop, try to show this film, but I'm not sure I will succeed. No, So I do second try with them. This is on YouTube anyway. You can search for Skogforsk, Autoplant, and there is 2 films, one from the beginning of the project and one with these field tests. So you can look at it there. Yeah, I think that was everything.
Okay. Thank you, Linnea.